Hello friends, so today's question. The coefficient of friction between the board and the floor shown in the figure is mu. Find the maximum force that the man can exert on the rope so that the board does not slip on the floor. So this is a man and this is the board M. Board is connected with the help of string which the man is pulling, and it is said that we have to find out the maximum force such that there is no slipping between the board. Okay. So in this case, first of all, let us assume that F is the capital F rather is the force applied by the man. We say let F be the force applied by the man. Okay. Next, we are going to define the mark the tension also. So we are going to have a tension T here, here, as it is single continuous rope, so the entire value will be same across the string. Okay. Now it is said that the board should not slip on the floor. So it means the horizontal as well as the vertical component should be balanced. You can see that for the board not to slip on the floor, first we have vertical forces should be in equilibrium, and second, horizontal forces should be also in equilibrium. Horizontal forces should be in equilibrium. Then only the board will not slip on the floor. So we already said that if F is the force applied by the man and T is the tension, then we can clearly see, rather say that the tension in the string, which is given by T will be equal to the applied force, that is F. And secondly, we already said that the vertical forces should be in equilibrium. So let us define the various forces which is acting in the downward direction. Okay. So we will be having a combined force of M plus capital Mg in the downward direction, and there will be a normal which will be acting in upward direction. Okay. And we can define that if this is the point where force is being applied, so force is being applied in the downward direction, and there will be tension T in the upward direction. Okay, and both will be equal. And another will be the force of friction. Let us denote it as Fr, which will prevent the entire board to move towards the right side. So for the equilibrium in the vertical direction, we can say for equilibrium in vertical direction, the summation of forces, let us call this as x direction and this as y. So we can say that summation of forces of y should be equal to 0. That means we have normal in upward direction n, and we have tension plus T, and downward direction we have m plus mg, should be equal to 0. From here we can find out our normal. You can see that n is equal to m plus capital M multiplied by g minus t. And let us call this equation number 1. This is equation number 2. Now the horizontal forces should be also in equilibrium. Okay, you can say that for horizontal forces to be in equilibrium, there are only two forces in horizontal direction. One is the tension T and another one is the friction force. So you can say that Fr will be equal to T. Now we are supposed to find out the maximum value of the force. So for maximum value of the force, we should be having the maximum value of the friction. Okay. For we can say for F to be maximum, that is F max, tension T should be maximum. Sorry, Fr should be maximum. And which is written as Fr max. Okay. We should be maximum. So we can find out our Fr max. So Fr max is equal to mu into normal, and our normal we already found out as per equation 2. Okay, so we can say that from equation 2 we get Fr max is equal to mu, and the value of normal is m plus m g minus t. Or we can, if you open this, we get, this will be coming as mu m plus m, sorry, if you open the bracket, we get mu m plus m g minus mu t. This is nothing but our Fr max. Okay, and we already know that force, applied force, okay, you can say from equation 1, F is equal to T, or we can also say our F max will be equal to our T max. Okay. And for the we have already written that Fr is equal to T, or from here we can say that Fr maximum will be equal to our T max. So we substitute this value, let us call this equation number 3. Equation number 3, yeah. So using equation 3, we get Fr max is equal to mu m plus capital M into G minus mu into T max. And Fr max is T max, we put here, we get T max is equal to mu m plus capital M G minus mu T max. This can be written as T max 1 plus mu is equal to mu m plus capital M into G. So it means maximum tension T max will be equal to mu m plus capital M into G divided by 1 plus mu. And we already know from equation 4 we can say that our F max is equal to mu m plus capital M G divided by 1 plus mu. So this is our maximum force. Okay. This is our maximum force which can be applied on the rope so that the board do not slip on the floor. Okay. This question was quite simple. Thank you.